Hi champ, how are you doing? Welcome into another amazing session of surface area and volume. And in today's class, I'm going to start a very interesting topic, the conversion of solids, and which is very important for your board exams for many Olympiads also. So make sure that you are practicing and writing every question in your notebook. So now champ, in this one, we will see different example. But before that, let's see the concept behind it. So champ, let's say we have a candle, okay? Now, if we will put this candle in the container and we will heat it up, then what will happen? We can see if the candle is getting heat up, then I can see champ that it will melt down, right champ? So now champ, that means the volume before the modeling will be equal to volume after modeling. Why? Because the amount of the wax will be exactly same now. The amount of material is initially and finally same. We have not taken any out and we have not put anything else. So amount of the material will be same. That means volume will be same. And that's the concept that we will be using. In this one, let's say we have a metal cube and we are melting the metal cube. And from the melting material, we are making the 6 spherical balls. So now, the material in the metal cube and the material in all the 6 balls will be same. That is why volume of the metal cube will be equal to volume of the 6 spherical metal balls. I hope it is clear. Okay, champ, so now let's solve some examples on it. Look at the first one. The dia of metallic surface is given to us. The sphere is melted and drawn into the wire of uniform cross section. If the length of the wire is given, they are asking the radius. So champ, do you know that wire is in the form of which shape? Is it conical, spherical or cylindrical? The wire is the cylindrical. So that means the volume will be same, the amount of material is same. So we can simply write the volume of the sphere 4 by 3 pi r cube. Dia is given, we can find the radius, volume will be 36 pi. Same, we can find the volume of the cylinder, pi r square h. We know the height, we know the r, right? And r is a variable, we have to find the radius. The simple champ, now both the volume will be equal, right champ? So simple, put volume of wire equal to volume sphere, pi r square h equal to 4 by 3 pi r cube. You will get the value of radius. Very easy. Excellent. Now champ, look at this one. In this one, a solid sphere of radius 3 centimeter is melted. Whenever melted or recasted, the same kind of concept. And then cast into small spherical balls, each of dia 0.6 centimeter. Find the number of balls thus obtained. And how many number of balls with the dia 0.6 centimeter we can make with the same material of this solid spherical, right? So now champ, that means the volume of this sphere will be equal to the total volume of these spheres. Let's say these small spheres are, spherical balls are n in numbers. So champ, the volume of solid sphere 4 by 3 pi r cube, radius we know that 4 by 3 pi r cube 36 pi. Now let's say we can make n small spherical balls. So their volume will be n into 4 by 3 pi r cube. 4 by 3 pi r cube, the volume of one small spherical ball. So volume of n spherical balls will be what? N into 4 by 3 pi r cube equal to volume of the solid sphere, 36 pi. Don't use the pi as 22 upon 7 because ultimately pi is going to be cancelled out. We can find the number of spherical balls. I hope it is clear. Very good. Okay champ, now let's see one more example. Look at this one. In this one, a well with 10 meter inside dia is dug 14 meter deep. Inside dia is given, height is given. Earth taken out of it and is spread all around to a width of 5 meter to form an embankment. Find the height of the embankment they are asking. So champ, we know that this will be a hollow cylinder type of thing, right? That means the volume of the earth taken out, dug out will be what? Pi r square h, the cylindrical form. The radius we know, half of 10. Height we know 14. We know the volume of the earth dug out. Now, embankment, let's see. Embankment will be something like this. So area will be what? Volume will be what? Pi capital R square minus small r square. Height we have to find. Volume will be into height. So simply, height will be what? Volume of the earth dugout upon area of the embankment. Why? Because height of the embankment into area of the embankment is the volume of embankment. So we are doing the same thing. The volume of embankment and earth dugout are same. We will get the height. Easy peasy? Very good. Okay, champ, now let's see one more. Look at this one. Water is being pumped out through a circular pipe whose internal dia is given. If the flow of water is 72 centimeter per second, that means in 1 second it covers 72 centimeter. Then how many liter of water are being pumped out in 1 hour? So we know that in 1 second 72 centimeter is getting covered. We know the radius. So champ, that means we can say length of the water column in 1 second flowing out is 72 centimeter. It will be cylindrical, right? So we can find the volume of the cylinder or the volume of water, pi r square h. This is the volume. But this is only in 1 second. In 1 second, this much volume of water is pumped out, but they are asking in 1 hour. So in 1 hour, 3600 seconds. So multiply by 3600 and divide by 1000 to convert in liter. You get the answer. Easy peasy? Excellent. Very good. Now, champ, let's see one more question. Look at this one. A vessel in the form of inverted cone. Its height is 8 centimeter and radius of its top, which is open, is 5 centimeter. It is filled with the water up to the brim. Okay. When lead sorts, each of the which is a spare of radius 0.5 centimeter are dropped in a vessel. That means in the vessel we are dropping the spare of particular radius. 1/4 of the water flows out. Find the number of lead sorts dropped in the vessel. We know that the volume of the water flows out is equal to the volume of the spares which they are replacing. That's it. So champ, the volume of water in the cone is 1/3 pi r square h. This is the volume. 1/4 of this is flows out, right? So champ, the volume of water flows out will be what? 1/4 of this, 50 pi by 3. So this volume will be equal to the volume of all these pairs which we have dropped in the vessel. So let's say we have dropped n spherical balls. So now champ, the one lead shot's volume will be what? 4/3 pi r cube. It's a spherical. We know the radius. Same champ, the volume of the n spherical lead shots equal to volume of the water flows out. We will get the number of the lead shot. I hope it is clear. Very good. So now champ, let's summarize our class. In this class we have seen that whenever we are melting any shape, any solid, and then from that melting material we are making any shapes. So champ, the same amount of material is being used again. If same amount of material is being used again, the volume of the initial shape and volume of the final solids will be same. That's the only concept. Okay? So champ, that's all for this class. Don't forget to practice hard, and stay tuned and be curious and keep smiling. Bye-bye.